સિરીઝ બાયસ્ડ ક્લિપર કેસ 4. આ કેસની અંદર આપણે એવું ઓબ્ઝર્વ કરીએ છીએ કે ડાયોડ આ રીતે મૂકેલો છે અને બેટરી એવી રીતે મૂકેલી છે કે બેટરીનો નેગેટિવ છેડો ડાયોડના કેથોડ સાથે કનેક્ટ થઈ અને ડાયોડને ફોરવર્ડ બાયસ કરે. પોઝિટિવ કે નેગેટિવ બંને સાયકલમાં બેટરી ડાયોડને ફોરવર્ડ બાયસ કરશે. એનાલિસિસ શરૂ કરીએ. Case 1. During positive cycle, the positive cycle will forward bias the diode. So positive cycle will forward bias the diode, and during the positive cycle, battery will also forward bias the diode. This means that an entire positive cycle, the diode remains forward bias due to both V input as well as VB. So for entire positive cycle, the resultant has to be found by calculating the series connection of both the inputs V input and VB, both the sources V input and VB, because during positive cycle, diode will remain forward bias and will behave as a closed switch. Now if we consider the case, let's see, we are talking about the positive cycle, and that is connected with the negative terminal of the battery. Cycle is positive polarity, battery terminal is negative, so plus minus opposite will result into the addition. Opposite will result into addition. Therefore V input will be added with VB. We'll get resultant by addition of V input in VB, and because V input and VB, we are dealing with addition and V input is in positive side, our final output will be positive throughout the cycle. Let's consider how it happens. Suppose now if we consider that V input is, for example, if V input is 0 volt, then V input plus VB will be equal to 3 volt if we consider input to be 3. Suppose peak of V input is 8 volt and VB is 3 volt, which is not going to be changed. So when V input is 0, output is 0 plus 3. Output is 0 plus 3, that is 3. When V input is 1, output is 4. When V input is 2, output is 5. And when V input is at its peak 8, the output is 8 plus 3 equal to 11. So overall in entire positive cycle, 3 voltages will be added. Every value of the input during positive cycle will get shifted upward by 3 volt. I hope the positive cycle is clear. Now let's concentrate on negative cycle. During negative cycle, V input reverse biases the diode, whereas the battery forward biases the diode. Hence the dotted line is kept in the negative cycle at VB volt. Dotted line in negative cycle at VB volt. Now because there is a dotted line, there are two cases. When V input is greater than VB, reverse bias is greater than forward bias. So the diode will be reverse biased and output will be 0. Now we are very well aware that in a series biased clipper, whenever the diode becomes reverse biased and behaves as an open circuit, there is no output voltage obtained. You can see in the waveform, for the region when V input is greater than VB, V input greater than VB, the diode will be reverse bias and will get 0 volt in the output. Case 1 of negative cycle. Now let's consider case 2 of negative cycle, when VB is greater than V input. Because VB forward biases the diode, so in this case when VB is greater than V input, overall forward bias would be greater than the reverse bias. So the diode will be forward bias during this time will behave as the close switch. So the output will be a resultant of V input and VB. The output will be the resultant of V input and VB. So, because this is negative cycle, let's calculate the polarity. We are talking about negative cycle, hence this terminal, this supply is negative and is connected with the negative terminal of the battery. Two similar terminals are connected. So for finding resultant, similar will result into subtraction. Now let's see how it happens. Because it is negative cycle and VB is greater than V input. So basically when similar terminals are connected, therefore there is a subtraction, and as VB is greater than V input, VB will be V input will be subtracted from VB. So it would be VB minus V input, and the sign of the final output will remain positive. Concentrate on this very well. The final sign of the output voltage will be positive because the positive terminal of the battery is connected with the RL. Here the decision making is upon VB because VB is greater than V input and we are subtracting V input from VB. So the sign will be as per VB, and because the positive terminal of VB is connected with RL, the output will remain on the positive side. Now let's consider how VB minus V input will happen. If VB is going to be fixed at a 3 volt, so when input is 1 volt, when input is 3 volt, it is like this case. When V input is 3 volt and battery also is 3, it is 3 minus 3 equal to 0 volt. When V input is 2 volt, it is 3 minus 2, that is 1 volt. When V input is 1 volt, it is 3 minus 1, that is 2 volt. And when V input is 0, 3 minus 0 means it is 3 volt. I hope you understand the reason behind this shape, and the same replica will be obtained this side when again input goes from 3 to 1 and then becomes 0. The case is VB minus V input. In this particular case, we can observe that the negative part of the input has been clipped. So we can name this clipper as negative series biased clipper. The case 3 was positive series biased clipper. Case 4 is negative series biased clipper. Again, let's remember one important thing. The waveform has to be continuously existing. Your pen, you should not have to lift your pen while you plot the output waveform, is a hint for checking whether your output waveform is correct or not. So all types of clippers are covered hereby. I hope you are learning well. Feel free to ask me the doubt if any. Thank you. All the best.